Hey guys, today we are going over one-step equations with fractions. This is part one. To review, we have properties of equality. The addition property of equality states that if you add the same number to both sides of an equation, the new equation will have the same solution. The subtraction property of equality states if you subtract the same number to both sides of an equation, the new equation will have the same solution. Some examples that we've tried before with whole numbers, such as 3 plus x equals 33. To figure out what x is, we do not use guess and check. We use these properties of equality. We're going to use inverse operations and subtract 3 from the left side and 3 from the right side of our equation. And so that 3 take away 3 is nothing, where we have x by itself on the left side, and then 33 take away 3 is just 30. So using the subtraction property of equality, we know that x has to equal 30. Over here, if we have an equation that states x take away 17 equals 20, we're going to use inverse operations. So to undo the subtraction, we add, and then using this addition property of equality, what we do to one side, we also do to the other. So negative 17 plus 17 is nothing. We're just left with x on the left. 20 plus 17 is 37. So using these properties of equality, we know that x has to equal 37. We're going to use these properties of equality and apply them to equations that involve fractions. So we're going to have to take what we know about solving one-step equations and put on top of that what we know about fractions. So our brain is going to be working really hard to remember all of our rules to solve one-step equations with fractions. So let's start with some equations. I've written the equations down and started the problem for you guys, but let's walk through it together. So in purple, you'll see the equation x plus 1/4 equals 3/4. So I have to use inverse operations to undo the plus 1/4. To undo plus 1/4, I'm taking away 1/4. 1/4 take away 1/4 is nothing. Then what I do to one side, I have to do to the other. 3/4 take away 1/4 is 2/4. 2/4 reduces to 1/2. So I know that x has to equal 1/2. I could plug that back into my original equation and check it. So 1/2 plus 1/4 has to equal 3/4. Example 2 in purple. Y take away 2/9 equals 5/9. I have to undo the take away 2/9 by adding 2/9. Take away 2/9 plus 2/9 is 0 on this side, so I have just y by itself, which is what I want. And then what I do to the left side, I also have to do to the right side. 5/9 plus 2/9 equals 7/9. So I know that y equals 7/9. I didn't have to reduce or simplify there. Okay, example 3. X plus 1/2 equals 2/3. I have to undo the plus 1/2 by subtracting 1/2. What I do to one side, I must also do to the other side. You'll notice here that I have fractions that have unlike denominators. So I'm going to have to rewrite these fractions so they have the same denominator using common denominators. Well, the number that 2 and 3 have in common is the number 6. 3 times 2 is 6, so 2 times 2 is 4. I just made an equivalent fraction. 2/3 is the same as 4/6. I didn't change its value, I just changed its appearance so that I can easily subtract. 2 goes into 6 3 times, 3 times 1 is 3. And again, I just changed its appearance. I did not change its value. I have equivalent fractions from 1/2 to 3/6. Now I could easily subtract 4 take away 3 is 1, and I keep the denominator the same. So I know that x has to equal 1/6 here. And then example 4, x take away 1/6 equals 7/12. Well, Well, to undo the take away 1/6, I have to add 1/6. Once I add 1/6, just cross that out because negative 1/6 plus 1/6 is 0. So I have x plus 0 equals this value. Now I'm going to add, but I do not have fractions with like denominators, so I'm going to have to change them so they have like denominators. Looks like 12 is going to be my common denominator. This first fraction already has a denominator of 12, so I don't need to change it. It stays 7/12. And then I'm going to change 1/6, so it has a denominator of 12. 6 goes into 12 twice. 2 times 1 is 2. And then I just add my fractions to get 9/12. I can reduce that actually. So x is going to equal, let's see, if I divide this by 3 and divide this by 3, 9 divided by 3 is 3. And 12 divided by 3 is 4. So I just reduce my 9/12 to 3/4. Do you guys see how I said it's a lot of information? You have to remember your one-step equation rules. You have to remember your fraction rules, your common denominators. There's a lot to remember to solve problems like this. To make it a little bit more challenging, we have some examples here with mixed numbers. Again, I've already started the first one for you guys. In orange, you'll see the original equation. N plus 1 3/5 equals 2 3/4. So I have to undo what's happening to n. So if I'm adding 1 3/5 to n, then I have to subtract 1 3/5. If I subtract 1 3/5 from this side, I also have to subtract 1 3/5 from the other side. So now I'm subtracting mixed numbers. I go back to my rules and I think, okay, I've got mixed numbers, I've got different denominators, I've got to change them so that they have like denominators. Common denominator with 4 and 5 would be 20. So 4 goes into 20 5 times. 5 times 3 is 15. That's how I got that number. 5 goes into 20 4 times. 4 times 3 is 12. So that's how I got that number. Now, to subtract, I just subtract their whole numbers. 2 take away 1 is 1, and I subtract their fractions. 15 take away 12 is 3, and I keep the denominator the same, since it's like denominators. And I check to see if I can reduce that fraction, and I cannot, so that's my final answer. Number 2, x take away 1 1/2 equals 4 7/8. That was my original problem. I went ahead and started some work here. To undo subtraction, I need to add. So I add 1 1/2 to both sides so I can cancel out what's going on here. I get x by itself. Then I have to solve this. 4 7/8 plus 1 1/2. I need to change this half so it has a denominator of 8. What an equivalent fraction to 1/2, but that it has a denominator of 8 would be 4/8. So I can actually add my ones. 4 plus 1 is 5. And then I'm going to keep my denominator and add the numerator. 7 plus 4 is 11. So I've got a whole number and an improper fraction. That's not okay. I need to change this. So it'd be 5, and I'm going to take out 8/8, which is equivalent to 1. I'm just going to remove it from this fraction part, and then I've got 3/8 left over. And now I'm just going to combine 5 plus 1, that represents 1 whole. 5 plus 1 is 6, and 3/8 is what I have left over. So again, that's a lot of rules that we have to apply to just one problem. We've got our inverse operations, our properties of equality, our addition of fractions or our subtraction of fractions with mixed numbers. It's a lot. So when you solve these problems, you really just need to take it slow, one by one. Make sure you show all your work, or else you're going to get really confused and really messed up. So just take it slow and show your work. You've got 4 problems to try for homework. Again, rewind the video, watch it step by step if you need some extra assistance. Good luck.